Hello and welcome. Today we are going to talk about another interesting topic, which is oscilloscope. And you know, these two things, function generators and oscilloscope, they are the two very important equipments in any measurement or instrumentation lab. Oscilloscope generally can be of two types: digital oscilloscope, DSO, digital storage oscilloscope, and another is CRT, cathode ray tube type oscilloscope. We shall talk about both of them briefly. Okay. So, let us start with CRT, which means cathode ray tube oscilloscope. Okay. So, this is one type, another is DSO, digital storage oscilloscope. So, let us talk about first how a CRT works. All of you might have seen this in your lab, but let us know what is there inside and how it actually works. This is made up of mainly a hollow tube like this. Okay. So, this is a glass tube and this is evacuated. So, and in one end we have an electron gun. This is an electron gun, and on the other end, this side we have a screen. So, this side we have this screen, basically some phosphor material is coated on this side of the glass. So, if I try to draw it in 3D, this will possibly look like this. I am not good at this drawing, but still let me try. Okay. So, this is the screen, and you generally have this markings, divisions like a graph paper on the screen. Okay. And you may have seen nice patterns like sine wave or anything on the screen. This is what is displayed, but what is there inside? One important thing that I already have said is a electron gun. What is an electron gun? It emits electrons. And then we will have some focusing arrangement. So, right now I am just talking about as functional diagrams or schematic. So, this is focusing arrangement, which will make these electron beam. So, this is a beam of electron, okay, being like something like a laser light which you might have seen. So, a small narrow light beam emits from a laser light. Similarly, a narrow beam of electron will emit from this. Particularly, the focusing arrangement will also take care of shaping these electron beams. and after that we have the main two components. These are two sets of plates. One is a set of horizontal plates, so these are the two plates, and there are two vertical plates like this. This is one, and behind that this is another. Okay. Now, what we can do is this. So, we can say apply a voltage between these two plates. Okay. So, you apply some voltage between these two plates. We call it V vertical VV. What will happen if you apply some voltage here and say if this this side is positive, this side is negative, then this plate is positive and this plate is at negative potential. Now, when these electrons are flowing through the gap between these two plates, they will get attracted towards the positive plate, which is the top plate, and therefore, the electron will take a diversion. If you apply no voltage here, so if you have 0 voltage, then normally the electron goes in a straight line through these two sets of plates and it hits the center of the screen. And when the electrons hit the center of the screen, because of the coating on the screen, you will see some bright spot on the screen at the center. Okay. If no voltage is applied here, you will get a bright spot here. Now, if you apply this voltage, then the electron is the path of the electron is diverted, and instead of going it straight, it takes a diversion and it will hit maybe this point on the screen. So, you will have a bright spot on the screen here. Okay. And if you say make this more positive by applying a higher voltage, then it will take more diversion, it will go further up and the bright spot will come further up. Similarly, if you have a small voltage, say only a small voltage here, slightly positive, then the electron beam will hit possibly here. And therefore, what you can do by changing this voltage, by making it more and more positive, you can drag this point up and up, or by making it small positive, you can bring it down close to 0. Similarly, if you say apply a negative voltage, say this is minus, this side is plus, then what will happen? This plate is positive, so electrons will get attracted by this plate and repelled by this plate. So, the electrons will come and hit down here. So, the bright spot that we will see will be here. Now, this is the function of these two plates. This is called vertical deflection plate. Similarly, I have two more plates which are put horizontally. Okay. So, one towards me and this is away from me, and I can again apply some voltage between these two plates like this. So, these two plates, let me put it here. So, if I apply a voltage between these two plates, call this voltage V H, okay, H for horizontal. Now, say if you make this side positive, this side negative, then what happens? Then this plate is positive and this plate which is closer to me is negative, and say there is no voltage here. These two plates are inactive. Then what will happen? Then when the electron is coming like this, when it comes between these two plates, it will get attracted by this plate which is farther from me, away from me, and therefore, the electron beam will hit here instead of hitting the center. It will hit here because it is attracted by this plate which is away from me. And similarly, if this plate is positive and this is negative, if this is negative, this is positive, then the electron beam will come closer to me and will hit here. And therefore, by that I can change this voltage, make it plus minus, or make it more plus, less plus, more minus, less minus, and therefore, I can control the position where the beam will hit. Okay. If this drawing is not clear, let me show the arrangement with a box. Okay. So, I have a box, assume that this is the inside of the tube, cathode ray tube, and inside it I have a electron gun. So, this is, assume this is an electron gun, and from this electrons come out. So, I keep it here on one side. So, from this electrons come out like this, electrons can come out like this, and on the other side here I have the screen. Assume that this blue paper is the screen of the oscilloscope. Okay. So, the electrons will come out from this gun and normally hit the center of the screen, okay, and it will create a glow at the center like this. Okay. So, we will have a glowing bright point at the center of the screen like this. Okay. Now, okay, so this is my arrangement. Here I shall put one plate, here I shall put another plate, and these two are going to be my horizontal deflection plates. What I do? I apply a positive voltage here and negative voltage here. Okay. So, basically I have this connection. Okay. So, I make this plate positive and this plate negative. Okay. So, what will happen is this electron beam will get attracted by the positive plate and it will hit here instead of hitting the center. So, it will now hit there, and we shall have on the screen we shall have a bright spot towards this side. If you see from the front, so we will have a bright spot here, not on the center. Okay. And now, if I make the voltage difference more and more positive, then this will go towards the left further. If I apply more positive voltage, it will go further towards the left, and if I bring the voltage down to 0, it will come to the center, and if I make it negative, it will go towards the right more and more, and I can bring it again back to 0 by making the applied voltage 0. Okay. Now, similarly, let us see from the top again. Okay. So, I have these two plates which deflects the beam horizontally. I will put two more plates like this, say one plate here, this plate is under the electron beam, and another plate which I cannot draw, but okay, I will demonstrate it this way. So, this is the other side of the box. Okay. So, this is the other side of the box. So, this closes like this. So, here on the top side I will put the other plate. Okay. And say I apply a positive voltage here and a negative voltage here. This is the electron beam. Now, you can guess what will happen if I close the box. So, that this plate is on top of this, then what will happen is as follows. The electron beam, while going straight, it will get attracted upwards, it will come upwards and hit here. On the screen, it will hit up here, not at the center. Okay. So, this way I can change the position of the electron beam. So, let me tell you once again what happens. So, you know that there are two sets of plates. Okay. One is the vertical deflection plate, another is the horizontal deflection plate. If I apply no voltage in any of them, the electron beam hits the center. If I apply positive voltage, only positive voltage only to the horizontal plates, then this will go towards the right like this. More positive voltage, it will go more towards the right. Less positive voltage, it will stay here. And if I apply negative voltage only to the horizontal plates, it will go to the left like this. Okay. Similarly, if I apply no voltage to the horizontal plates and a positive voltage in the between the vertical plates, then the beam will go up, more positive, more up, and if I apply negative voltage, it will go down, more negative, it will go further down. Okay. Now, what will happen if I apply say simultaneously a positive voltage between the positive plates and between the horizontal plates and a positive voltage between the vertical plates, then this beam will move like this and will come here. Okay. So, let me just mark the center. Let this be the center of the screen from the front. Okay. So, if I apply simultaneously positive voltage between the positive plates and the negative plate between the horizontal plates and the vertical plates, the beam will go like go like this, come here. Okay. So, what I just have said is that if I apply simultaneously positive voltage here, that means negative here, and if I apply say positive here, that means negative here. So, then the beam will go up and towards the right, then the spot will be created here. Okay. This is for VH and VV, horizontal and vertical, both positive. Now, let us think about what will happen if I apply continuously changing voltage to these plates. Okay. Now, suppose V V is equal to 0 and V h is a function of time and it is changing with time. And let me tell you how it is changing. It is changing in this way. This is time, and then initially it is 0, or say initially it is say negative, and then it is increasing linearly like this. It goes up to this positive value and then it immediately becomes negative again. This is time versus V horizontal, okay. And then here again it goes like this and then comes back again to negative. So, this is a ramp. So, this is a ramp. This is a ramp signal which we have applied between the two horizontal plates. So, then how will the electron move? So, if we see from the front, so this is the front view, this is the screen. Okay. Let this be T0, this time is T0, let this be T1, T2, T3. So, we want to find out where the electron beam will be on the screen at this different times. Okay. So, this is the screen. And you know that the vertical voltage is always 0. So, the electron beam will always be centered with respect to the vertical line at say t equal to 0. Horizontal voltage is negative. Okay. So, therefore, the electron beam will hit here towards the left. So, it will be here at t equal to 0. At t equal to 1, this voltage is 0. So, it will hit at the center, this is T1. At T2, it will hit here, because the horizontal voltage is positive. Okay. Then at T2 and T3, this is the same time, okay, same time actually practically. So, this is T2 also same as T3. Then at T4, it will come back again here. At T5, it will be at T4 I have made a mistake, this is not T3. So, T2 and T3 which is also almost very close time, practically same time almost. At T3 it will be negative, it will be here, this is T3. At T4 it will be again here. At T5 it will be positive. So, this way it will oscillate. So, starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, so on. So, it will move like this slowly from left to right and then suddenly to left, slowly to right, suddenly to left. Okay. So, this is how the electron beam will move. And if we see, if I try to animate this, this will look like this. So, center, front please. Yeah. So, here say initially the electron beam is here at T0, this is T0, then T1, T2 here, and then back, then again gradually like this and back suddenly, again gradually slowly like this and suddenly back. Okay. This is how the electron beam will move like. Now, say what we do, we apply simultaneously a voltage between these two plates. Okay. So, let us apply voltage, let us apply V simultaneously. Previously it was 0, not simultaneously. Okay. And how VV will vary? Let us draw that. Okay. So, let us draw VV. VV will look like this. Time versus V. This I will take it like this. I will take it like a sine wave, which is like this. So, it completes one cycle in exactly same time as it is taken by this horizontal voltage to complete one cycle from negative to positive. This is one cycle, this is also one cycle. Now, I apply this type of voltage. Okay. If I call this time period is t, okay, then the equation of this voltage should be V V is equal to some amplitude times sine omega t, omega is 2 pi by t, where this t time period is same as this time period, okay, multiplied by time. This is how it varies. If so, how will the electron be moved like? Okay. So, let us see how it will move like. At t 0, at this instant, you see horizontal voltage is negative. So, the electron beam will be here towards the left, somewhere here definitely, and what will be its horizontal position? Horizontal position will be 0. So, this will be the position at t 0. Now, after that you see this voltage, horizontal voltage is increasing gradually. So, the electron will move from left to right, but simultaneously the vertical voltage is going down. So, therefore, as this beam is going towards the right, it will also come down. Okay. So, therefore, say here call it t half. At this time, this is t half. Okay. So, the electron beam will come here like this. It will come like this. This is t half. Then after that, it will go further towards the right, because this is increasing, and it will go up because this voltage is now increasing. So, here it will go like this. This is T 1, this is T 1. Okay. And after that it will go towards the right again, but now it will go up also like this. This time you call it T 1.5. So, this is T 1.5. After that what will happen? So, this time is actually this time. After that it will go further towards the right, but simultaneously will come down. So, it will come down like this. So, this is what has happened up to this moment, okay, here. And what will happen next? After that, you see the horizontal voltage is 0, slightly before this and slightly after this. So, the electron will remain on this middle line, but this voltage is becoming suddenly negative. So, after this the electron beam will come immediately to here, okay, and then it will trace trace the same path again and then come immediately back here, and then again this sine wave and so on. Okay. If I try to animate this for you, okay, so how it will look like is this. Initially the beam is here, then it goes down like a sine wave, half wave, then up and again down, and then immediately back, once again down and up and then immediately back. If I could repeat this process very fast, if the frequency is high, then you shall see a sine wave actually like this. If I can do this very fast, or what you can do, you can repeat this part of the video by playing it very fast in your media player, then you possibly will see that it looks like a sine wave traced on the screen or on the paper. So, this is how the cathode ray tube oscilloscope works. We shall talk more about it in our next class. We shall also talk about slightly briefly about digital storage oscilloscope. Thank you.